Okay, welcome to the next video in my series. I think it's been a long-awaited one. I've been asked to do this one for several years now, so I'm finally getting around to it. What I'm going to be doing is showing you how to do georeferencing in ENVI. And so what I'm going to be doing is taking a panchromatic image and I'm going to be bringing that in, and then I'm going to take an aerial photo and I'm going to bring that in, and the aerial photo is just a JPEG, so therefore it doesn't have any um, it doesn't have any coordinates that are associated with it. So what we want to do is adjust that aerial photo to the panchromatic image. So what I always suggest first is open the image, the master image, which is the one with coordinates. And I'm just going to pull it up here. I just made it the messy way of doing it and assigning it there. So I'm going to bring in this. Now remember that with ENVI, we always want to use the largest file, which is our TIFF file. I'm going to bring that in. And so we have this nice panchromatic image. Now just remember that we can always apply any kind of contrast enhancement if you need to. So if you don't like the way this looks, we can go to maybe Gaussian, or maybe there's a linear 1% that you like. Whatever you find is going to help you visualize the best is what you're going to use. So I know that the next image is going to be of SAIT, so I'm just going to zoom in here. So for those of you who are across the world, this is the institution that I work at. And now I'm going to bring in the JPEG files. So I'm going to open that and I'm going to bring in my JPEG. And you're going to notice that right away it doesn't show up in the right spot. So my JPEG is my slave image and this is my master image. So here's my slave image. It's set at 0, 0 in terms of the pixel coordinates. So we can see it's sitting here. You can see the area that it covers. So we can see that there's the river here and SAIT's up here. If I go over to this, I can see SAIT's here and I can see the river down here. These are also taken from different years, so that's going to add to the fun a little bit on trying to get this done. So to go from there, now if we want to do some georeferencing, we're going to go over to the toolbox and we are going to say registration, and we're going to be using this image registration workflow. ENVI has a great workflow. It's fantastic. It helps provide tie points, which I find very beneficial when you're working with images because it's not necessarily a straight, rigid transformation. So in ENVI, they refer to our master image as base and our slave image as warp. So make sure that you choose the correct one for this one. So the base image is my master, so I'm going to make sure that I choose the TIFF image that has the coordinates. Then I'm going to choose the warp image, which is my slave image, which is the JPEG. So all I do is just click browse. It is going to tell me what is in the layer manager, and it will also give you the images that you have available in your data manager. So you just make sure you choose the right one when you do it. So here we've got our two input files. I'm going to click next. It's going to load and it's going to give you a split screen. So we can see that now this one's showing here, and then I have to click to be able to adjust this one. So making sure that you click left and right when you're going to be working with this. Now in this window, I'm not going to describe everything to you, but it is some options that you can adjust. So because there is a machine learning algorithm here, we have automatic tie point generation. So if you want to get into that, you can go take a look at how it's matching. There's two different versions of the algorithm here. You can also filter, so it'll give you matching scores. You can also use a geometric model for fitting and what kind of transformation you like. These are all just to create tie points to be able to apply the registration. The advanced tab is now whether you're going to use what band you're going to use to be able to do the registration. Even though we can visually see that we have an RGB image and we have an intensity image on the other side, so between the two of them, we can you can adjust that based on what it is going to use for the actual matching band to create the tie points. We're not actually talking about the registration in this point at this point. All it is that machine learning algorithm to figure out tie points for us. Now, as with most algorithms, we need to set a tie, like the seed tie points, which means it's going to tell the algorithm these are the places that are correct. So with that, actually, I just noticed that I didn't look very closely. That looks like an airplane going over. Anyway, I got a little distracted there. Okay, so what we see is when we go to the seed tie points tab, we have an empty table. I'm going to pull this over to the side. Now, the one thing that you really want to do is make sure that you get in the middle of the smallest image. Whoops. So if we go over here, we know that we need a point that is in this close to the center of this image. If you do anything on the sides, it's actually going to kind of break the algorithm. So you want to make sure that it's somewhat close to the center. So I'm going to, I have two screens, but I'm going to try to like keep these off to the side as much as I can. So again, I'm going to zoom out here. I'm going to find where Sate is. There's Sate. I'm going to pan it over. And I need something in the center, so that looks like something in this area. And zoom into that and go over on this side. And so we can see that we have two different resolutions, and that is often very normal for us to have two different resolutions. So don't be so super shocked when you see that. Now what you're going to try to do is find a object that is well defined as much as you can, that is the same. So looking at this, it looks like this building here would be the same as this one here. And we have the sidewalk that's coming up. So even though this one doesn't seem to turn, it's because it's not as high resolution. So I'm going to select that corner, and then over here, I'm going to select this corner here. Now that I've got that, I'm going to go back here, and I'm going to click Add Tie Point. So you can see that the number 1 is here and number 1 is here. That tells me that that's the first tie point in the same location. Now I can start doing my tie points anywhere that I have in both images. So I'm going to zoom out a little bit, and I'm going to go over to my corner over here, and I'm going to see what I can find to select. So this is only in 2 dimensions, so just kind of keeping that in mind while you're working with this. And this object here, or this like spring greenhouse, is the same, but it's a little bit challenging to try to determine where exactly the corner is. I could say that's a corner, but I'm not sure if that's the same corner here. So that might not be a really good option. This is different than here, so we know that something has changed in the area. So we need to find something that is actually the same. So what I'm going to do is I'm going to look at roads. So up here, I've got this nice little triangle here. And in this side, whoops, I'm going to see if I can find that same triangle. I can see the curve here, but I don't see the triangle. So again, that is part of what this whole experience is all about. But what I could do is possibly find something in the center of this bridge. So I'm getting as close as I can to being the same, and I'm going to select the center of the bridge, and then I'm going to click Add Tie Point. Now, as I go through this, you need to have 15 tie points in order for this. Well, you need a total of 15 tie points when you generate this. I am going to just do a couple examples of what I would expect when you do a tie point, because you want good geometry. I'm so used to using not one screen. It doesn't like me when I do that. Okay. Yes, I know I need a tie point. Okay. So now I can try to find the same point in here. And that's further down, I believe. There's that road. And this one, so I can see that this is that road that's running through here. I'm going to try to get this corner down here. Again, I have a building. Generally, you don't want to use the tops of buildings because we can have an angle that's associated with it. Sometimes it's difficult to try to find points that are not buildings. But there's this location here, it looks like some sort of maybe a bush or something. That looks close enough, so I can press pause. Again, I'm not going to go through this entire thing showing you where you should put all of your points, but you should have an even distribution across both of the images as close as it can possibly be, because there's going to be some distortion, and that will get it to generate. Now, because I don't have a pause option on here with this video, I'm just going to do this very quickly and trying not to talk too much, so it might be really boring. And I'm just going to only do 5 on each side, and I'll explain why that's bad as I'm going. So when you are looking at your images and you're trying to create a registration, one of the more difficult things that happens is that you end up with a bias if you don't have enough seed points. And so the seed points, even if they're perfectly distributed throughout the entire image, those like a few seed points now. See, I just overwrote my point that I had over here. So this is what happens when I did the edges too soon. Okay. I lost my middle point. So, usually this does not happen. It's only because I'm recording today, so that is why it's going to give me some issues. But I can still find that point again with no problem. Okay, so we have one here, and we had one here. I'm gonna think, give us my 3. Okay, now I can continue on. Like I said, I'm only going to do 5 with this, but you want to do 15. The more you have, the more reliable your solution is going to be. So we have the turn here, the turn there, so we're looking at this intersection. Try to get the middle of the road. You can see how a close estimate is usually good enough for this. If you are really having a hard time trying to find something, especially when there's natural features, that can cause a lot of problems for you. So I suggest to try to get as close as you can, but remember that you're often going to be dealing with different resolutions, and that's going to create an issue. Okay, so I've done 5. This is not ideal, but I'm doing this as an example, so that's why I want to kind of move forward on this. So I've got my 5 tie points. In order for me to do a proper registration, I want to have 15 as my minimum. Now, one of the things that you can do is, let's say I want to come back to this and work on it. So I've been working on it all day, and I want to be able to come back and work on it, or I'm afraid that something's going to crash when I press next, which sometimes happens. I'm going to use the save tie points. This one is specifically for looking at my seed points, and so it's going to help me build what I want to relate to. So this is seed tie points, and it's a .pts file. So when I save that, then it's going to show up in my data, and so if I double click it open, let's give it a second. Oh, it's going to show up in my Leica software. Never mind. You can open it up as an ASCII. So if you open it up with Notepad, it will work just fine. But I've got it now opening in 3 different ways here. So it saves these values are in pixel coordinates, and that's going to allow you to find those exact points in your pixels. Okay, so now I've got those. I'm going to click next. What this does now is it uses those seed points to create more tie points. Sometimes it goes up, sometimes it goes down. So if you end up with a reduced number of tie points, it means that there's likely 1 or 2 of them that are poorly placed and it couldn't solve for the solution. Where in this case, in my case, I'm hoping that I have 15 points. If not, I'm still going to push it through just for the purposes of the video. And this is the automatic tie points. It's going to try to say, okay, I've generated them, and now I've got 32 tie points. So that is what that first step does, is it allows it to create additional tie points that we can use to apply the transformation. Now, depending on the transformation, the more points you have, the more flexibility that those points can actually move around. So you can see that some of these have pretty high errors in your RMS value. You should always have 1/10 of a pixel when you are dealing with your registrations. So if I'm just going to use an example of a like 30 meter, if I was using Landsat, if I have 30-meter resolution, then I need to have a RMS under 3. This one with my registration here, my pixels are approximately 30 centimeters at the best, maybe possibly a meter. So it would be 0.1 that I would be going for. Now the RMS is in pixels in this case, not in meters. So just to kind of keep that as as that. So we're looking for a tenth, so we'd be looking for like about 1. If you needed to remove any error, like any of the large values, you would go and you would click on error, right click it and say sort column reverse. What that's going to do is put the highest errors at the top and the lowest on the bottom. In order to filter them, you're going to delete the highest point. And so let's say I'm going to go with 2 is my RMS that I'm aiming for. So I can see now my full RMS error has gone down to 2.4. I'm going to delete the next high error. And now it's at 2.25. I can delete the next one again using the red X. Notice that I don't highlight all of them and delete all of them that are high. The reason for that is because every time I remove one, the error adjusts. And so I can keep as many points as possible and try to reduce my RMS as much as I can. So you see here that I have my RMS of 1.95. That is just below the 2, so that's what I would be aiming for depending on what my resolution is for my pixels. And once I've got that, I want to double check that my warping parameters are good. So this is where you can change your resampling algorithm and your warping method. So there is the rotation, scale, and translation, which is a rigid transformation. There's a polynomial, which is less rigid, and triangulation, which is even less. So you can apply whichever warping method you think is appropriate. I'm going to leave mine in polynomial. The resampling, there's 3 versions. There's nearest neighbor, bilinear, and cubic convolution. You can go back to my lecture and hear about all the differences of those. So depending on what your needs are for the project, you can choose that resampling option. In data ignore value, if it has a 0 value, it's going to ignore it. And the output extent is going to be the full extent of the warp image. So if I were to say overlapping area only, that would mean that I actually have a image that is partly on the master image. So then it would only show that. So pixel size, the base image has a much higher resolution, so it might help me with the warp image. It may not either because it is so pixelated in this case. I can also adjust the export options. So there's 2 options here that we can see. The first one is the warped image. So it's going to give me an ENVI file. I can change it to a TIFF if I prefer, if that's a little bit more flexible when you're moving between softwares. But the .dat files also go into Esri, so if you're looking to move it into a GIS platform. So this is the actual image itself. Then there's also these tie points. So there's 2 different things to do. So this one has output tie point file, which is going to give you your RMS values. If I go here and I save these ones, so this, remember this is under review and warp, these tie points is going to give me these RMS values as well. But I cannot use this in warp from GCPs. So this one is just a table. This would be what I could give to a client if they need to know that. So I'm going to definitely save that. And so this one is raw tie points. That, hit save. So now I've got that one. And then in my export, I can export them to an ASCII. So here I'm going to save them again. I'm going to say this one is my final tie points. Hit save. Now I've got both of those saved, so I can always go back. Every time you see a little save button, you may as well just save it, because you can always go back if you save it. If you don't save it, you're not going to be able to go back. So there is the option to preview your results, so it will show us what it is seeing. So if I zoom out here, I think it's just going to show me where this is. And so that doesn't really look so helpful, but you can see how all your tie points are in this image. You can see there's a bias. We're missing some up at the top here. If that top part is important, you would have to go back. So if I go to tie points here, I would need to start adding points and adding points in this corner. If that corner is not as important, then I could possibly leave it and just make a note that anything in that corner is not, there's no control in that corner. So that's just something to keep in mind. So then we click finish. Everything's going to get exported. And it will output the result. There we go. So in ENVI, it does keep the, turn this one off so I can get rid of it. It does keep the original JPEG. So my suggestion is to right click and say remove, and then it goes away. Now here I can see where my image is placed. Now one of the things that you might want to do is highlight that warped image, because it's the final warped image, and apply a transparency. So this scale is a transparency, and you can see how the registration worked. So for example, this is quite a steep hill in here. So if I zoom in a little bit and I apply this transparency, you can see how the shift, there's a terrain difference. If I needed to be orthometric, I would have to go through an orthometric registration as well, and correction. And that would, I would use a DEM to correct for this for the weird like compression of the hill here that you're seeing. So that is also something that if your client is very concerned about and that you have to apply it so that it is an ortho image, that is another step that you can do if you have the DEM for the area. So that wraps up my georeferencing component. Again, this is a way to be able to do this. This is one way. There's of course you can go image to map, or if you have ground control points that you've collected in the field, you would be able to apply that too. But this one's specifically for image to image registration. Thank you so much for joining me today.